show this photograph, and every time it will be Rio and will show this photograph. I make it again, Chile, Rio. So, first a few words about what is New Caledonia. It's an island. It is the largest lagoon in the world, and this lagoon has 1,700 species of fish. New Caledonia is close to the highest zone, the zone of highest marine biodiversity in South Pacific. And well, along these 8 years, I was blessed by the visit of Ian Whittington on his team. Also for the Kenyans, a visit by Eva, which, as you can say, like coconuts, and of my students. And as you know, there are so many fish and so little time. So we examined about 3,000 fish. We found 2,000 host parasite combinations, and we published about 700 of these host parasite combinations. That's what about 100 papers published, and that means more than 1,500 pages of systematics. Of course, with many collaborators in various countries and my students. So, how do we evaluate parasite biodiversity on host parasite lists? This is an example. This is the example that Andy showed with the species named A, B, C, D, because I had absolutely no imagination. All these are congeneric species of Pseudoarthrocynosus in a single species of grouper, and other groupers have also a large number of species of monogeneans. As you can see, 9, 11, 12 species of monogeneans. Just a word to tell, of course, that biodiversity of Diplectanis in grouper is not restricted to New Caledonia. There are a lot of species in Central and South America, and we have seen a poster about new species from Parentias colony, and I really expect to see that species published soon by the authors. So, groupers, example with groupers, we examined 28 species. We found about 50 species of Diplectanids, and also a few other monogeneans. So finally, we published about 70 species of Diplectanids. More of them, of course, were new. Only 70? No. Because if in addition to the morphological work, if you do some molecular work, this is the work in preparation by my student Charlotte, just an example for the species that in morphology we call Pseudoarthrocynosus jungi, molecules can show that you have in fact at least 3 different species. So there are probably more than 100 species of Diplectanids in these 28 species of groupers. What are the methods to evaluate biodiversity from lists? That is not so easy. Method, like collection of fish, collection of parasites, then you send the material to specialists. Rod Bray, Ian Beveridge, Mark Moravec, Ian Whittington. Whittington, you know it, is about monogeneans, the other is for digeneans, cestodes, and nematodes. They publish, you have also many unpublished results. Then you prepare a host parasite list. This is the host parasite list only for the family Serranidae. I think it's 12 pages, single interline. And how to evaluate biodiversity from this list. I will show you a few examples. A simple example. How do you evaluate biodiversity? How do you count host parasite combination? It is extremely simple. The host parasite combination is a line in a list. So here you have 5 lines, it's 5 HPCs. But you have a level of taxonomic precision. It can be at the level of species, or genus, or family. In this list, you have 3 species which have been identified at the level of species. That's why we call the SLIP, species level identified parasite. The others are not. So in that case, you have 3 SLIP HPCs. Another example, easy, 2 fish, Lepectanids. You count the number of lines, 4 HPCs. You count the number of binomial, I mean the number of complete Latin names. You have 4 binomials, so it's 4 SLIP HPCs, and the total number of parasite species is 4. Easy. Less easy. These are results about Digenians. Number of HPCs, you count the lines, 3. Number of SLIP HPCs. No one of these species has been identified at the species level. So SLIP HPCs, 0. What is the total number of parasite species? Is it 3? Is it 2? Is it 1? We decided to take a minimalist approach. So in that case, we decided it is 1. We have good reasons to believe it's probably 3 or 2. Certainly not 1. But we always took a minimalist approach. And finally, the total number of parasite species with this minimalist approach is 1, only 1. Another example, we find cestode larvae, a lot of them, tetraphilid larvae. Number of HPCs, you count the lines, 3. Number of SLIP HPCs, nothing, it's impossible to identify that the species level is larvae, so it's 0. What is the total number of parasite species? We have good reasons to believe that it is probably 50 in each fish. And by the way, I have now molecular results that show that, well, maybe it's not 50, but it is a lot in each fish species. Same thing, we keep a minimalist approach. If we cannot have Latin names, we consider it's only 1 species. You understand how minimalist the approach is. So, with this method, let's see a few results on 4 families of fish. Groupers, 28 species examined. Lethrinids, if you work in the Pacific, you know them. If you don't work in the Pacific, you don't know them. They are all in the Pacific with a single species in the Atlantic. We have seen 17 species. Lucianids, we worked on 2 kinds of Lucianids. We have Lucianids which are reef associated, and we have Lucianids which are deep sea off the barrier reef. In this study, I will speak only about the Lucianids of reef. And Nemicterids, the red fin on the right is probably one of the most abundant fish in the lagoon. Nemicterus corposus. It's everywhere. A real pleasure to catch it with that. So, results on ceramides, host-parasite combinations. I'm not going to read it. I give you 5 seconds to read it correctly. And we have 75 species identified. Lethrinids, you have your 5 seconds. We have 42 species identified, 42 slips. Nucleonids, Again, you can see 5 seconds. And 25 species. And it's only 5 species of fish, so it's less. And 15 species identified at the species level. 15 slips. So if we put all that together, we have for these 4 families of fish 148 slips, or about 600 HPCs. Slips, it's different parasite species, but again, a minimalist approach. We see that if we find the same parasite species in several fish, we count it only once. Now, we can look at something more interesting, which is the mean. This is the mean number of slips per fish species. So the result is about, for the 4 family of reef-associated fish, 2.64. But if we look now only at the well-sampled fish, I mean the fish for which I had more than 30 specimens completely dissected and examined, the results are better, and we have this result of 9.62 slips per fish species, about 10 species of parasite identified at the species level per fish, and about 20 HPCs. Now if we look only at monogenia, you will see that the results are extremely disappointing. It's only 1.11 slips per fish species. This is very low. We all know the papers by Susan Lim or by Ian Whittington. The papers say that the biodiversity of monogenia is something between 3 to 5 monogenians per fish species. What reasons for this? Probably sampling. Too many new species. It took me 1 year to describe the 12 species for one fish, so too many new species, no time to finish it all. Rare species, and probably also cryptic species. So, my very bad results on monogenians simply mean that the work was not well done. All this is published in 3 papers. And again, the 2 first papers were presented in Chile, and the 3rd paper is presented only now. This is why you have 4 families of fish. About this paper, I would like to comment a little bit, especially for students. These papers are fundamentally very boring lists of Latin names. They are extremely difficult to publish. For the first one in Folia, I had to fight to have it accepted. It's a very long paper, 26 pages. They were not enthusiastic about it. It is, I think now, the most cited paper, the second or the first cited paper of Folia for 2010. For the second one, it was rejected by Parasites and Vectors. And the reason was, one of the referees said, it's like old Russian literature. Rejected. The 3rd one was rejected by close one, because the sampling is not adequate. Only 400 fish. We published it in Aquatic Biosystem. This is a screen copy. I did it this morning, and as you can see, the paper has been accessed 7,000 times in 11 months. So this is just to encourage students. Do not hesitate to publish boring lists. There might even be people who will read them. At least apparently 7,000 people have downloaded this paper. Yes, of course, I click on it every morning and every afternoon. But even that, in 1 year, I cannot click 7,000 times. So, result about this number of fish, if we count everything, the main result in 2 lines, you can write it down if you don't want to download these beautiful papers. The main result is 20 HPCs per fish species and 10 parasite species per fish species. Be careful, this does not mean that each fish species has only 10 fish parasites, because the species of parasite which are common between several fish are counted only once. Again, minimalist approach. So, last question. How many parasites? How much do we know? The main result? Can we generalize? I believe we can. We have unpublished results. I am preparing the next paper about carangids with similar results. I will probably have it rejected by 1 or 2 journals. We have 1,700 species of coral fish. If we can make a prediction of 17,000 species of fish parasites. This is only metazoan. I do not include microparasites and so on. So that's a prediction. And what do we know? Well, this is the type of humidity on the base. So we know about 2% of what has to be known. This is after publishing 1,500 pages of systematics. You can imagine what has to be done. And of course, we have acknowledgements to all my friends. Thank you. Thank you for the excellent talk, and it's open to questions. Martin.
Do you think that the phytoparasite associations and the parasite numbers will hold with the rare hosts?
Yeah, I understand the question. Yeah. Well, we have results. We have results for some rare tipsy fish that maybe are not that number of 10, but it's not really good. It's not really good. In fact, we even had a surprise when we compared the Lechianis on reefs and the Lechianis on deep sea, which are really rare, and we had more parasites in the deep sea. But it was an artifact because my colleagues preferred to work on the deep sea fish because they were so exceptional, they were so happy to have so many new species.
There is a positive aspect here. All those 400 names are correct.
I hope so.
Yeah. If you look at those, there are 400 names, 1/3 is wrong.
In the minimalist approach, that you only use full binomial marking species. Have you also considered they work with multiple species that you have to completely scratch that you can solve on?
That's exactly, yeah, we do the question also. We have time.
Okay. So considering this minimalist approach that you only use full binomials to count the species, did you also could you increase resolution by using multiple times that you can distinguish, that you don't describe? Yes.
We could have increased our resolution. We could have increased the numbers, but we want to keep a very minimalist approach. So if you had to that, what we have not done, it's probably not 10, it's probably 20. But it's easy to prove that it is 10 if you have different names. If you have multiple species, people have to believe that you have 15 different species, and so we with the minimalist approach, we can only combine it. It's probably 2 times this number, or 3 times.
And on which most taxonomic level did you do that approach? Because if you find a piece in a certain genus in several families of fishes or several orders of fishes, did you then at some point start assuming that it's a different species, or you just keep?
Yeah. For the host, we used morphological approach only. Charlotte has done, in addition to that, Charlotte has done the cryptic species of fish. That is a completely different story. And if we add cryptic species of fish, we have of course additional biodiversity, parasite biodiversity. All that. Okay. So, I'm going to share now. So we have a presentation by Carlos Mendoza Patero. And it's about the astonishing morphology of freshwater monogenians of catfishes on the Peruvian Amazonia.
Good afternoon, everyone. My name is Carlos Mendoza. I'm from Mexico. I'm doing my PhD in the Czech Republic under the supervision of Tomáš Scholz, who unfortunately couldn't come, but he sends best regard to this. In this presentation, I will talk briefly about diversity of catfishes in the Peruvian Amazonia, and then I will talk about what we know about monogenial parasites in this fish. And then I will focus my presentation on the findings in the Peruvian Amazonia, and finally I will talk about future perspectives about this project. So as you very well know, the Amazon River harbors more than 2,000 species of freshwater fish, and an important component of these fish belongs to the order Siluriformes, mostly known as catfishes. So what we know about the dactylophyrid monogenians, or this fauna present on this fish? Well, so far, approximately 73 species have been recorded on this fish, but only in 52 species of hosts. So if you saw the poster of Emmanuel yesterday, so we still have a lot of things to do, a lot of work to do, especially in this group of Siluriformes, and also in other groups like Parasitoformes. So our findings in the Peruvian Amazonia. So first of all, this is our region of study. This is Iquitos, Peru. This is located in the north part of the country. So this is Peru. This is our region of study. So in this region, we have examined catfishes from the family Primeloridae, Calictidae, Auricaridae, Auchenicteridae, Doradidae, and Pentapteridae. We have carried out several sampling trips to Iquitos from 2004 up to 2011, and more than 100 species of catfish have been examined. And in these fishes, we have identified, or we have found 96 species of undescribed monogenians. So this is a big thing, I guess. From all of these total of species, I will take a very interesting example. So this is our host, Agenios vittatus. So it's not a very good looking fish, as you can see. It's not very tasty either, but it's very interesting because of its parasite. So in this fish, we have found 11 undescribed species. So you may think that 11 species is not a big deal, but the problem is the complexity of the morphology of these monogenes that I am about to show you. So because I'm still a student, I'm still learning, and I'm still trying to understand the complexity of this group. So we said we need help. We need a superhero who could help us to describe these monogenes and to understand the morphology. This guy was very busy and he couldn't. So we found another superhero in Curitiba, and I visited his lab last year in August. So we were working on the taxonomy of these monogenes. So this is our protagonist of the story. So this is our morphotype number 5. So at the first sight, you may think what is astonishing about this monogene. So it looks pretty standard for a dactylophilid. So I will show you in detail what we found that we never seen that before. So first of all, we found a muscular sucker-like structure located right below the pharynx. So in a series of pictures, I will try to show you the composition of the structure. So you can see here, this is the structure which is still circular. And if you go to the ventral part, so you can see here the opening which forms kind of atrium, which probably will go back again. So this is the atrium. Probably guides the circulatory organ. So this is the first structure. And then we were looking for the prostatic reservoir and the seminal vesicle, but we couldn't find them. So instead, we found an organ which we call prostatic complex provisionally. So this organ is composed of 4 cells, as you can see here, the nuclei. So this is the one. So this organ is connected to the base of the main copulatory organ by this way. So this is another example of the organ. So you can see here the nuclei, the cells, and then this is the exit or the connection of the organ, which goes up, and then turns here and enters to the base of the main copulatory organ. So if you have an idea what is this organ for, this new. And then we were looking at the germarium, and so we found a U-shaped germarium. So if I understand very well, the germarium basically is like a pineapple. So the 6 mature oses are in the anterior part, and the immature oses are in the posterior part. But in this case, the mature oses are in the ventral position, and the immature oses are in the dorsal position, right here. What about the sclerocyte structures? Well, they are pretty simple, or they have no modifications like spectacular modifications. So this is a main copulatory organ, this is the accessory piece, the anchors, the bars. So they look very, I would say, very standard for a monogene. If we look at the hook pairs, some of the hook pairs, if we compare them to other species, parasites of catfish, like cosmetic lacrum or Aphanobactera, they look pretty the same. But if we look at the hook pair number 5 and number 6, they are extremely As you can see here, this is the thumb, and it's drastically reduced, and the end of the point of the hook, it ends like too long. It's not sharp like in other examples. So this is our say. So we were saying this after looking at this structure. So based on these morphological features, we are proposing a new genus, and 5 additional morphotypes can be included in this genus because of the morphology. So we still don't have a name, so if you have some suggestions, they are very, very welcome. And finally, in a preliminary phylogenetic analysis, including only 3 morphotypes of these new genus. So apparently they form a monophyletic group. But of course we have to go deeper in this analysis, maybe to try other genes. And future perspectives of this study is to complete the description of the new genus, including all of these morphotypes, and to add more sequences of the rest of the morphotypes. And as Tomasz said, or Tomasz told me many times, you have to finish your PhD as soon as possible. Finally, I would like to thank all my colleagues from the Institute of Parasitology, and our colleague from Switzerland, Alain de Chambrier, our contact in Peru, Martin Mortenthaler, and all the students from Walter staff who helped me a lot during my stay in Curitiba. Meninos and meninas, muy obrigados. Thank you for your attention. Thank you very much.
We have time for a few questions. Martin.
Well, actually, we were thinking that if just guide the first thing, the first thing that we were talking about was just the only purpose of this structure is to guide the manipulatory organ, but actually it goes like this. If you look at the lateral view, it goes like this. It forms kind of atrium, so we still don't know what is this structure for.
Is it broad enough that it's around the edge?
Well, probably. Very good idea.
I see an idea.
Yes, probably. No, in this case, no. We found these like individuals on the ears, so we didn't find it. We didn't find them there.
How many specimens have you examined? Specimens of
this morphotype. So we have a lot, like maybe 35. So some others are fixed in gap. So for the books and the answers and bars.
Do you see them alive?
Yes. I don't know, it was really hard because if some of you have been in Iquitos, it's really hard to work on the field in these conditions. So we didn't have much time to look at the live worms and to make some drawings or something like that.
Only?
In the absence of watching the worms move, what does the pharynx and any anterior headbands look like? So have you seen the worms moving? You haven't. What does the pharynx and what does the anterior headband look like, or the anterior suckers? Choice of better word.
Well, not really, because during our, let's say, our sampling trips, or when we were examining the fish, these worms don't move much or don't change the size like in the case of Hydrodactylus, so they don't move like this, just stay there and just move around. So when you are dissecting the fish, they don't move much.
Thank you. One question. Thank you very much. If I understand well, this is the last for the last. So this is a presentation by Antoine Parizel about the simple, fast, inexpensive and effective method to amplify monogeny and DNA from fresh or fixed specimens. This is not a student presentation.
Well, once again, I have a very short presentation. I want to apologize for this because I am moving, so I have not enough time to prepare. I will try to keep you in mind for 5 more minutes. Yeah, so I have checked, I have been trying to check some articles on the genetic sequence, and you know this is obviously a very important tool now for a lot of reasons by the and our worms, I mean my worms, the Orthosocotella are bigger, but our Orthosocotella are very small, and the one I'm working on, the good boys and others, are really small. So the DNA extraction is not easy. And I have tested, and you have all tested, a lot of different techniques to extract the DNA, and this is the list. And well, we have used these techniques, and the results are we are able to amplify at the best 80% of our samples. And the samples are very, very hard to get, and very expensive. So we try to find a new, that's probably not new, but another way to extract the DNA. So we take the specimen of the it's living or fixed, where we may identify by putting the specimen on the slide in the gap, and then use it for DNA expression and sequence. I have done it a lot of time because this paper has been rejected, and one of the references probably said you could not use gap and then take the specimen in gap to find DNA. I've done it a lot of times. So anyway, so you have to watch it for 1 or 2 times in a course for 3 hours. I tried with the oil medium in comfort, or something like that. And if you use that for 5 years, I tried to take a flight. I have done 5 years ago, and with that. So the method is extremely simple. You take 2 milliliter drop tube, you fill it with fluid. Drop 50 microliter of water inside, and then you put your specimen, and then drink the specimen with a micropipette, like that. So the micropipette is previously heated in the left. I mean, you seal the canal and you run the extremity. So it's at the beginning, and then you just push on. You have later and wait and and then you use it to squash your specimen, and then you have to use it directly for this here. So we set it as a concentration of DNA, so it's drop on the microgram by English pointer, and it works directly. And it works in 100% of our so we have taken to 0.05 microliter all the 80 microliter. It was well. No, we are 100% and it's direct, no protein cannot, only water. So you can make more than 100 here. There's only one word in English. It's not new, I mean, I don't know. Someone tell me one word, the same one from me, it's not new. But I checked and they use potential media. We use nothing except what. So, this is, you have to test this, but it's for me. Okay, thank you for your attention.
Any questions? Lastly,
I don't know, but I never seen a paper saying you just watch the when I work, I start my work, long time ago we used CCAD, and then now it's daylight salvation, because you just use the gem or something like that, we have to paint, and then we lose a lot of DNA, washing the, and it takes time, and then you go to your,
The other trouble is that investors want to organize. You can't keep them for an extended period.
I put in a different time.
Yeah.
Yes, the articulation is also my question. You had a 50 microyears of sample, and isn't enough for 150 hours? How many samples is it for your school?
I use from 2 to 0.05 milliliters.
And it was concentration in one reaction, or the concentration of the sample?
Of the 50 milliliters, I squash the,
Yeah.
then I take and get the
Concentration of sample. Okay. So if you took from it 1 microgram reaction, or how, what is the volume of the sample in different reaction?
what do you mean?
Did you then dilute further before you do the reaction? Or how much did you take?
I take from 2 microliters, which is the quantity I usually use, and then because it works a lot, so I decrease the volume, and then 0.05 microliters. 0.05. So it's supposed to be, you're supposed to have 300 here with only one word.
So you dilute.
You put this,
But you didn't say.
I take.
Yeah, and are you able to take 0.05
Yeah.
microliters
One here.
in the process? Are you able to?
I tried there, if I test with the 5 microliters maximum, so I was very
Okay.
maybe it's only the fact that you DNA on the seed. But, I mean, 0.05 is stupid. Then, not because you may have another. Very small, very good, on your side.
And the second question is, what about storage? If it is 1 word, and you said 4, actually,
I put it in the refrigerator. For the time being, now I have 100%. Before I have only 58%. With myself. So I win 20%. So I win a lot of money. But now, before I use everything to steer all the house volume. Now I have a lot of. So there is so much giving that you may put in the refrigerator and
never ending. Martin?
Have you done a time series to see how long it will go for?
yes, sure.
Any comments about the use of the malware liquid before that? Because I'm really surprised to see the specimens that they've been in
I was referee.
No, I am surprised because specimens that have been in filtrate for 1 minute.
Yeah. I don't think
Yeah.
I'm fine, that's why it's
Try again as well, and
I have no agreement.
do it control.
Just for the.
Try again, to make sure you have control, so you have a flush word.
Sorry, we are done with the sequence. We see two different.
But you have individuals that are preserved,
Yes.
I can suggest a good law.
¿Alguna vez?
Carlos, después vamos a tirar las fotos.
Si lo haces sí.
Mas eu achei que era antigo, que era...
Não, mas ele usa aqui do micro.
Fica bem concentrado pra falar do o dele é maior.
Well, that was the last scientific law of the conference.
012 e 300.
Thank you everybody. I think we can